Hi, I'm Beth Ann Lopez, an RU student this summer in the Weitz group, and I'm going to tell you about our research with microbubbles.
If you are what you say you are, a superstar, then have no fear. The camera's here and the microphones, and they wanna know, the return. If you are what you say you are, a superstar, then have no fear. The crowd is here and the lights are on, and they wanna show, yeah.
Microbubbles are useful because they are great ultrasound contrast agents. Our bubbles are fabricated with nanoparticle shells. We make our nanoparticles by putting a batch of silica precursor into a solution of alcohol and ammonia, and you get silica nanoparticles the next day. They are uniform in size, and you can control their sizes by adjusting the reaction conditions. The powerful thing about using silica particles is that we can use organoalkylsilane functionalization to customize them in the microbubbles. You can easily make them hydrophilic, or attach specific molecules to the particles.
Though I need a holiday like lady who sung blue. Go back, whatever you did, you undo. Heavy as heaven, the devil on me 2 tons too. If you are what you say you are, a superstar, then have no fear. The camera's here and the microphones, and they wanna know, yeah.
I was making bubbles then, and I'm making bubbles now. And the problem with the bubbles that I was making was that whenever I made them, I got different sizes, different shapes. Sometimes I'd get shells, sometimes I'd get particles that looked like they'd have little dimples in them, and sometimes I'd get the ginormous bubbles, sometimes I'd get itsy bitsies, and there was just no control over that process. And so then I was attracted to this lab because I could make bubbles that were all the same size.
In order to overcome the design challenges Wynter talked about, we used glass capillary microfluidics. This technique was developed by Andy Utada, a scientist in our own lab group. The microfluidic devices are made from glass capillaries that are heated and pulled to make a very controlled apparatus for making bubbles. These devices enable us to make highly customizable bubbles where we are able to control bubble gas volume, shell thickness, and bubble size. Furthermore, all of the bubbles we produce will also be uniform in size.
The audience ain't phased, and they ain't gon' clap, and they ain't gon' praise. They want everything back that they paid, cause they've been waiting since 10 to see the lights get dim. If you are what you say you are, a superstar, then have no fear. The crowd is here and the lights are on, and they wanna show, yeah. So show first.
We produced monodispersed bubbles using a double emulsion template in which nanoparticles were dispersed in a volatile organic solvent. Upon evaporation, the oil suspension formed a shell of packed nanoparticles surrounding the gas bubble. However, this alone was not enough to stabilize the bubbles. We hypothesized that this is due to low surface tension in our organic solvent, and in the future we plan on using more viscous oils to aid in bubble fabrication. Once the issue of solvent viscosity is solved, we will have developed a set of techniques that enables us to fabricate stable, uniform microbubbles that function as customizable ultrasound contrast agents.
If you are what you say you are, a superstar, then have no fear. The camera's here and the microphones, and they wanna know, if you are what you say you are, a superstar, then have no fear. The crowd is here and the lights are on, and they wanna show, yeah. If you are what you say